In this video, what we're going to be doing is taking those new skills that we had for solving systems of equations, and we're going to put them to use in word problems, which nobody likes. But although this is unpleasant, being able to use a system of equations actually makes this a lot better than actually most classes teach like basic word problems before they do the systems, and I think those are much harder. So let's get started and I'll try to show you what I mean. Okay, so when I make these, I'm going to jump ahead. Oops, sorry, don't know what happened there. So when I make these, what I do here is I make my dictionary, which is I'm going to define the idle nose. And what's good about this, when we have a system, is we don't have to like figure out one of them in terms of how it relates to the other. Normally like one is X and then you build the other one off of that one. We're just going to say we've got two people and we don't know their age. Okay, so I've got Devin and Cooper. Okay, now we're going to make our equations based off of this. So there's always an easy one, or at least I should say most of the time. And here's my easy one. If we add the two of them up, we know their age is 50. So I've got one very simple equation. Just add Devin and Cooper. There's my dictionary. D and C add up to be 50. Now, it just so happens here, this isn't all that typical, but the second equation, we need two equations because we have two idle nose so that we can make this a system like we've been handling in the last sections. So this one happens to be the second equation is built off another one. Devin is, okay, we're going to translate this from English into math language. Devin is D, is an equal sign, 26 years older than Cooper. Well, isn't that 26 more than Cooper? Now, we have our system of equations, and we can use any of the methods that we've learned before to solve it. Now, do you see this is set up already, though, with D equals? So substitution would be a natural fit here. And that's what they'd use. They're going to sub D equals this. We're going to drop it in for D. If D equals C plus 26, well, then let's put it in where D used to be. Tidy that up and solve. And we're going to get C is 12. Now, it asked, I think, it asked for both of their ages. I'll just assume that it is. So if you needed both of their ages, well, if this is C is 12, we can know Devin is C plus 26, and we have our second one. Okay, so I'm going to make my dictionary here. I'm going to use X's and Y's. I don't like this is Jake, and this is his dad. Now there's usually just a simple, straightforward one where if I take their two ages, they add up to be 42. Now in this case, we're going to be able to build a second equation from this sentence here. Dad is 6 more than 3 times Jake. Now you build it one word at a time, just moving across. The only thing to watch out is less thans will make you flip the other way, but we don't have any of those here. So I've got this set up. If I know y equals this, I'm going to use substitution. Drop this in for y. It's supposed to be a plus there. So I've got 4x plus 6 equals 42. Oops. So I'm subtracting 6 from both sides. Nope. Okay, sorry about that. X is 9. Now, just like we would have done before, I know it's a word problem, but let's just plug it back in. So if I could use either equation. So if I know X is 9, let's put it into this top equation, and I've got 9 plus Y equals 42. So y must be 33. So Jake is 9 years old, and his dad is 33. Okay, now let's see if they did their dictionary here. So here's our dictionary. We've got two machines. So somebody goes to the gym or is we're going to the gym. They're spending some time on the elliptical and burn some calories. They spend some time on a circuit trainer and burn some calories. So now there's typically a super easy equation. Now we're going to lose this here, so let's flip here, but it tells us, oh, we don't have a simple just add them up, but here's what she did. She rode these machines twice. So she spent 10 minutes burning calories on the elliptical, 20 minutes burning calories on the circuit trainer. Wouldn't that be the total number of calories on each of the machines? And it tells us the first time she worked out, she burned 278 calories. Well, she came back to the gym again another time. She spent 20 minutes on the elliptical, 30 minutes on the circuit trainer. Put those together, she burned 473. So calories plus calories equals total calories. Calories plus calories is total calories. That makes sense. Now, look what we have here. This is a system of equations where elimination would be the best approach. I'm going to run a negative 2. Well, I would do. Let's see what they did. I would run a negative 2 through the top there, yeah, which is what they did too. And then they've multiplied all the way through and created this new equation. Now, the reason we did that is that creates these opposites, and the E is going to just drop out of there. And so we solve this, we get C is 8.3. Now, let's plug it back into either of the equations. It doesn't matter which one. Put 8.3 in there, crunch it down. E is 11.2. Okay, so I'd recommend you pause this and give this a shot. But I'm going to go ahead and start. So X is going to be calories rowing. I should say it's really the rate of calories run, the rate she's burning them. And then the other machine is what? Lifting. So it's the rate she's burning calories, lifting. Okay, so she's doing 30 minutes on the rowing machine, and that would be how many calories she burns. So 30 minutes at this rate. We've got 20 minutes at this rate equals a total of 430. Okay, the next time she's spending 50 minutes doing this, 10 minutes doing that. We get a total of 600. Okay, now I hope you see that elimination would be the way to go here. And I'm going to run through a negative 2. Okay, so I ran that through in order to create the opposites there on the y. I get negative 70x equals, I don't want to think. Let's let my calculator do that for me. Okay, so we get negative 770. All right, we got x is 11. So that was x. Now, just like we would always do, we could choose either equation to set it back into to solve. I'm going to choose the top one, but it wouldn't matter either way. Okay, so just subtracting 330 from both sides. Y is going to be 5. Now, these are the rates of calories being burned. So if you wanted to label them, this is 11 calories per minute. This is 5 calories per minute. Okay, so this is a real common type of problem. And complementary and supplementary angles. Now, in order to do these types of problems, we need to remember a basic principle of geometry, which is complementary angles are two angles that add up to be 90, and supplementary add up to 180. And the way I remember this is C is before S, and 90 is before 180. So C before S and 90 before 180. So complementary 90, supplementary 180. Okay, so let me see if they did their, yeah, they went ahead and made their dictionary. I don't know what they kind of a typo there. I'm not sure what they're doing and why they used X and M. Is that really what they did? No, that should be a Y. I don't know what they're doing. Okay, so they should have X and Y. So I've made my dictionary. It's not super vital on this one because it's kind of obvious, but let's now build the equations. Yeah, so here's where we're going to build the two. Now, the first one students usually find. The difference of the two angles is. So the difference of those two angles is 26. Now, the one that they struggle to see is, like, where's the other equation? Well, the other equation is in the definition of complementary. we know that if we take these two angles, they add up to 90. And so I create this system of linear equations down here. And if you notice, we're already set up to eliminate the y. So all we have to do is add up. We get 2x equals 116 because the y's are gone. So they didn't finish that. No, is that right? Sorry, it's been a long day of doing math at the university, and I am not thinking. Okay, so cut that in half, I get 58. Now, if I know the one angle, all I got to do is put it back into the other, and I get y is 32. Okay, give this a shot. Pause the video. So this dictionary is not super helpful, but I got x is the first and y is the second. Now it says the difference of these two angles is 20. And so you're like, where's the other equation? Well, they told us that the two equations are complements of each other, and c and 90 go together, and s and 180 go together. Okay, so I get this. Now we are set up for elimination because I have the opposites on the y, so I've got 2x equals 110. X is 55. Okay, now use either equation you want, doesn't really matter. I'm just going to use 55 plus y is 90. And I have my second angle. Okay, try another one. This time notice that it's supplementary. I'm going to make my dictionary. I always make my dictionary so I don't get confused. Okay, the larger angle is, now it really doesn't matter which you made. You could have called one larger, and I just called them first and second, but we'll just say larger is 12 more. We're going to translate one word at a time. 12 more than 3 times the smaller. Okay, we need a second equation because we got two I don't knows. Well, they're supplementary, and we saw that if you add up two supplementary, you get 180. Okay, now we've been doing elimination, but this one is set up for substitution, so I'm going to go ahead. I know what x is, so I'm going to put that in the other equation. Okay, y is 42. Oh yeah, I forgot if I had done both. Okay, so there's my first one. Haven't done both yet, so I'm going to plug this into either equation. Now I can do the top, but that's going to be a little more work, and I'm naturally lazy, so I'm going to choose this bottom one because that's easier. Right, I have x plus 42 equals 180. Okay, that's supposed to be an 8 there. Okay, so my two angles are 42 and 138. Okay, so let's get a diagram here. So they're telling us that we are interested in knowing the length and the width. So I'm going to make my dictionary. Okay, so we know that his house is blocking part of it, so I don't need to worry about his house. Yeah, they're going to tell us this. Well, let's see if they build them for us here. Okay, so we need two equations, and they're telling us that one length and two widths equals 125 because it was the perimeter equation. So what's implicit usually in all these kind, they're telling us the amount of fence that we would use. And if you do fence, that's the perimeter where you just add up all around the outside. Well, we don't have to do the house because it doesn't need any fence. So what we're doing is two W's and an L. And they told us we got 125 fence. So we've just done the perimeter. Okay, they also tell us the length will be, so length is 5 more than 4 widths. Okay, well I've got this set up for substitution. I'm going to drop that in, crunch it down, I get 20. Put the 20 back into either equation you want, you get 85. Okay, so I'm going to have the length, and I'm going to have the width. Okay, so just like before, if it's these kind, I'll draw the picture. But so I got the house here, so I don't have to do this side. And I've got, oh, okay, well it's two long sides and one short side, so it doesn't really matter, but I'll just make those sides longer. Okay, so they tell us we need 155 feet of fencing. So I'm going to start with the perimeter. Yeah, this isn't really going to change anything, but I'll do this, and the house is over here. So the perimeter is if you add up around the outside. So I've got two L's and a W, and I've got 155 feet of fencing. Okay, now let's make a second equation. The length of the long side is 10 less than the width. Now be careful, less than makes you flip it around. So this reads 10 minus twice the width, but it's not. It's twice the width minus 10. Less than flips you around. Okay, now we're ready to go, and we know the length, so we're going to substitute this in. So I've got 2 times 2w minus 10 plus w equals 155. 4w minus 20 plus w equals 155. That's a bad w. Okay, so we get our width and we get 35. Now we can use either equation that we want, doesn't matter, but I'm going to use this bottom one here because it says that the length is twice the width minus 10, and that'll be 60. That's 70 minus 10, so I get 60. Now you really should be putting units on here. I'm pretty generous about that with my students just because word problems are hard, but if you want to be technical, you should do that. Okay, let's do another fence one here. Love it if you'd pause the video, give it a shot. Trying to see how many sides we got. Okay, so this is what they're saying. So they've got some neighbor's fence, so we don't need to fence that. This is needlessly kind of confusing, but I'm going to just go length and width, and we don't have to do this side. Now, my dictionary is obvious. I'm going to skip this. So W would be width, length is length, L is length. So we're doing our perimeter. We've got two widths plus an L plus a length. Gets us 136 feet of fencing. I'm just adding up the outside fence. Okay. Okay, now we've got our second one right here. We're just going to translate this one word at a time. Length will be is the same as is. 16 less than twice the width. Well, less than flips it around, so it reads like 16 less than twice the width. But less than makes it go the other way around. And we have this. Okay, we're already set up for substitution. I've got 2w plus 2w minus 16 equals 136. Okay, am I right about that? Yeah, I think so. All right, so we've got our width. Now let's go ahead and find our length. So I'm going to put that back into this one. Crunch that down, and that's going to get me 60. Okay, so I'm going to put some feet on here. I'm assuming it was feet, yeah. All right, I'm assuming we have one more section with some more of these. I'm not quite sure. I think so. Some harder ones perhaps, but that'll get you started. So I always make my dictionary. You're then you have to build two equations, and you're think of yourself as a translator. You're taking an English word and switching it over into math language. You go one word at a time.